ASTM E814 UL 1479. We'll get more into that a little bit later on. For membrane penetrations, it refers you back to the same test. There's some discussions going on currently about membrane penetrations, especially where a penetrating item, especially a metal pipe, penetrates one side of a wall, especially wallboard, and then turns up and goes into the wall for a period of 1 foot, 2 foot, 3 meters, 4 meters, whatever, and then turns out of the wall. And the question is, will the membranes, that would be the wall assemblies, maintain their integrity with that metal pipe inside the wall heating up a whole bunch? FCIA sits on UL's standards technical panel. We had a meeting last August to talk about this particular risk. And we're going to work together with UL and the manufacturers to make sure that the membrane penetrations have the appropriate testing. That's why FCIA is involved in the code development and the standards development process, is to make sure that the field perspective gets brought to the code development process and the standards development process. Let me go back real quick to the code and take a quick look. That was the penetrations. Coming over here to the International Building Code under joint systems, we'll find a couple other test standards. Scrolling down under the fire test criteria, it talks about ASTM E1966 and UL 2079 for joints. These would be for wall-to-wall joints, head-of-wall joints. It would also be for other joints as well. There's a couple of joints that are not included in the code yet. One is the continuity head-of-wall joint, which is a new standard that's not yet in the code. Could be specified, but it's not yet in the code. I'll try to bring that up later on. The other standard that is in the code currently is this one, ASTM E2307. And this is for the curtain wall assembly for extending the rating of the floor out to the outside edge of the building. There's an exception to ASTM E2307 in the code where ASTM E119 would be allowed to be used for those curtain wall areas as well. So ASTM E2307, UL 2079, UL 1479, ASTM E814, and ASTM E1966 are all referenced in the code. For our friends in Canada, you'd be looking at ULC S115 as the test standard that sits in the National Building Code of Canada for the requirements for fire stopping. The only standard that's not in the National Building Code of Canada's ULC 115, S115, is the perimeter fire containment assembly. That perimeter fire containment assembly, the ASTM E2307, is something that's specified in Canada for curtain wall type joint assemblies for the testing. If you look at the building codes, NFPA 101, Chapter 8, International Building Code, Chapter 7, fire resistance is defined as time in minutes or hours that materials or assemblies that withstood a fire exposure is determined by test methods based on tests or this code. In the ICC area, we added one word in the 2007 supplement cycle for the International Building Code. We put in Chapter 7, and nowhere was it before, the one word called systems. And you'll see why in a couple of minutes. We've talked about this at previous webinars. There's many different types of fire-rated assemblies, especially when it comes to walls, whether they're exterior walls, fire barriers, fire partitions, or smoke barriers, or smoke partitions. This one, the firewall, was spoken about at the during a news conference from the Edgewater Apartments in New Jersey. It talked about firewalls used in buildings. I don't know if I'd use that as an example of why firewalls should be in buildings and what they should be made of, because frankly a firewall could be made out of gypsum drywall and could be concrete block, could be many other things as well. So a firewall, though, has one characteristic in that it's continuous from the basement through the roof assembly and maintains its integrity even if one side of the building completely falls down. Key point in firewalls. Key thing in both the U.S. and Canada is this thing called continuity. Fire resistance rated construction has to be continuous. and provide continuous fire resistance. The holes, the doors, the dampers, the ductwork, the glazing, all's got to be fire resistance rated. One key thing about smoke barriers, there's an L rating required, air leakage rating, and it says right in the code under the 2015 section, under smoke barriers, joints in smoke barriers, take a look at this. We're right here at 715.6. I'll make it a little bit larger so it's easier to see, and then move it as well. So fire-resistant joints and smoke barriers have to have an air leakage rating. We'll get to what the air leakage rating is in a second, but it shall not exceed 5 CFM, cubic feet per minute, per lineal foot of joint at 7.47 pascals of water for both the ambient and the elevated temperature tests. So the L rating, no less than 5 for both ambient and elevated temperature tests. Then if we were to go back into penetrations, we'd find the same language under smoke barriers. Let me go back to smoke barriers. Maybe it's easier to find it there. So in smoke barriers, we would find that in the penetrations, there'd be an air leakage rating required for penetration. So it sends us back to 714. And under 714, I've got a slide for that. It'll talk about less than 5 cubic feet per minute per square foot of opening area as well, and then a quantified L rating for 100 square feet of wall area, meaning the 50 CFM per 100 square foot of wall area. This is a key thing to remember because this is where the codes and the standards kind of mix together. Codes dictate that we have a certain quantified L rating. The test standard says you come up with the L rating by testing the sample by a certain way. In this case, in the International Building Code, it has a quantified air leakage rating. This 5 CFM is what you would find for joints and penetrations both, and it's been in the code since the 2006 version of the International Building Code. And then in smoke barriers, there's also a requirement for less than 50 CFM, cubic feet per minute, per 100 square foot of wall area by the International Building Code in the 2009 cycle that went in. That was mainly for the healthcare type applications. The key thing about this 50 CFM per 100 square foot of wall area means that somebody has to look at a 1 meter by 1 meter, 3 meter by 3 meter section of wall, 100 square feet, 10 foot by 10 foot square foot of wall, and then count up the number of penetrating items and see if it exceeds 50 CFM for the L ratings for those for that area of wall. What does that mean? That means somebody has to specify it because it says to in the code, and then somebody has to count up the penetrating items through that wall and make sure that the Firestop systems that they chose meet that requirement. Under the NFPA codes, there's no quantified L rating required, but NFPA 101 asks for a continuous barrier through concealed spaces, and it also says to restrict the passage of smoke. Even though it doesn't say the word L rating, if you think about it, in a court of law, if a judge were to ask the question to the Firestop contractor or the professional specifier, what did you specify for that wall? If it's a fire barrier, a smoke barrier, we specify whatever we wanted with no L rating. Well, there's already another code, the International Building Code, that has limits in it. Secondly, the L rating needs to be specified as well, because the L rating is the suitability for use statement of the Firestop product in a smoke-based application. The ASTM standard will always win, or other standard, could be a UL standard, could be another standard, but the key thing is that the standard, the industry standard that says something it serves a certain purpose, will win in a court of law over a contractor, distributor, or manufacturer statement saying, yeah, sure, this stuff will work in that application. So be careful about that. Other testing and standards, most of the Firestops were developed from the nuclear power plant industry from the 1970s. So you'll find that many of the products may have radiation resistance. Ask the manufacturer. The International Building Code for high-rise buildings has a blast resistance. Check with the manufacturer to see what the Firestop blast resistance is. Some of them are very chemical resistant, some are not. check with the manufacturer to see if the physical properties of the products match up with what the conditions of the building are. And then biological agents, germs. At the University of Illinois Molecular Biology Laboratory, the architect specified a silicone-based firestop sealant for the whole perimeter of the building. At the time, there were spray products and cheaper products that could be used. Many tried to switch the specification but were unsuccessful because the architect had worked with the industrial hygienist from the building owner's staff, and they determined that to stop germs that they would need a product that would stop moisture flow through it, and the silicone did that. Maybe there's latex products that will do that. Maybe there are non-silicone-based products that will do that too now. Check with the manufacturer. Let the manufacturer's industrial hygienists who write the MSDS sheets, the safety data sheets, SDS as they're known now, have them work with the building owner's industrial hygienist so that the two of them come together to say that germs won't spread or biological agents won't spread. That due diligence should have been done before the contractor shows up on the project. That way, the specifications are very specific about what could be used for those types of applications. I've gone through this slide on every one of the presentations I've given the last year, so I won't spend a lot of time on it. I guess what I'll just say is that it's not just sprinklers that make a building safe. These statistics in high-rise buildings that show that fire resistance is in the buildings, alarms are in the buildings, and educated occupants are in the buildings means that it's all the types of construction that make a building safe. It's not just a sprinkler. It's about all the types of fire resistance-ready construction. I haven't spent much time on this slide at various presentations. This is a critical piece, and it's interesting that the NIST, the National Institute of Standards Technology, in Canada it would be your National Research Council of Canada. These two organizations actually work together on this World Trade Center collapse report for the number 1 and then the World Trade Center number 7. In Chapter 4.6 of their report, it says factors that could have mitigated the structural collapse, ... were improved compartmentation in tenant areas to limit the spread of fires could have mitigated the structural collapse. Got to be careful how you interpret that. Does that mean that maybe we build compartment areas of 10,000 square feet or less in order to slow the spread of fire? That might have been a way to do that and have the standards help with the code. Fire resistance rated constructions made of all kinds of different things. All of the different pieces of compartmentation, the dampers, the doors, the glazing, make for a continuous fire-rated system. Tested and listed systems are what we're all about. We match the blurry tested and listed system to the openings on the right to make sure we've got tested and listed systems that make things work. What test standards are in the code? We talked about this a couple of minutes ago. ASTM E814 is the test standard from ASTM. It is not exactly the same as UL 1479, and that is typically the biggest mistake people make. There is no L rating specified in ASTM E814. It's only in UL 1479. Does that mean that UL is the only lab that can test the UL 1479? No, that test can be run other places, but the standard that's used is UL 1479 to run that test. FM 4990 is FM's version of ASTM E814 and UL 1479. In industrial facilities and other facilities that are insured by FM Global Insurance Company, you'll find that this standard, FM 4990, is requested. The ULC S115 incorporates all of UL 2079, which is standard from UL for joints, and UL 1479. So L rating is possible in Canada. W rating is possible in Canada as well. The difference between ULC S115 and UL 1479 is the pressure in the furnace for the plastic pipe. And hose stream test is optional in some cases. So those are the two big pieces to watch for, such that if a system is a ULC S115 tested and does not have the H rating, it would not be suitable for use in the U.S. Also, U.S. systems that are tested to the UL 1479 that don't have the 50 Pascal furnace pressure may not be suitable for use in Canada in multifamily applications with plastic piping. You have to check the specific requirements, code requirements for that as well. So the test standard is suitability for use statement for the Firestop products in certain applications. All of these products have been tested for various applications. We will do another webinar throughout the year that'll be a 4-hour webinar to cover all these things, the advantages and disadvantages of the products that are used in specific applications. Look for that webinar sometime in the summer. We did one in January for our Middle Eastern friends that want to take the FM or UL Firestop exam. That's our study guide presentation for that exam. If there's enough demand for it, we'll do it sometime in May or June, but really our schedule is pretty packed. Look for it in July. Fire dampers, this is a big question in testing. Can I put Firestop around the damper? Can I put Firestop around the angle of the fire damper assembly? Should I put Firestop where the angle touches the duct itself? These are all really good questions. What should take place? First of all, dampers are tested to UL 555 and 555S. And there's also a C and an R. The C would be the sealing damper, the R would be a radiation damper, the S would be a smoke damper. The straight 555 would be the fire damper. Firestop sealants, it was believed, could not be used in the angular space behind these angles because it was thought that the louvers wouldn't be able to turn, because as the intumescent sealant expanded behind this angle, it might restrict the movement of those louvers inside the damper and cause the fire damper not to work. Testing has proved that it can be used, but you have to consult the manufacturer and the authority having jurisdiction to be sure that Firestop sealants can be used in many different places on fire dampers. The first thing to do is check and see with the manufacturer, can Firestop sealants be used around the angle of the duct? The UL 555 and 555S show the integrity of the internal fire damper to make sure the fire doesn't spread through it and that fire doesn't poke through the assembly itself. But what about the smoke? I'm not sure there's an L rating for the fire damper where the fire damper goes through the wall from the outside of the fire damper through the inside of that angular space, unless there's a tested and listed system. This tested and listed Firestop system around a monster fire damper allows Firestop sealant to be used around the perimeter of that damper using clips on one side, and then if you were to go to the other side of the fire damper, you would find angles around the perimeter of that fire damper. So one side's angles, the other side is Firestop, and it's gone through the damper test assembly. That fire damper test is quite amazing, where they burn it for a period of time, and then at the other side of the damper where the ductwork is extending, there's a drop test where they drop a 55-gallon drum full of sand, hit the duct to see if it'll knock the assembly through the opening or out of the opening. It's an impact test, similar to the hose stream test, in addition to the hose stream test, so it's a second test, believe it or not, to make sure that things that fall in a fire, ceiling tiles, pipes, big, huge pipes such as cast iron and steel, if it hits that duct, breaks it, and hits the duct, will the breakaway connections let loose so that the damper stays in place in the wall? Very important stuff. So physical properties are needed for Firestop products. Systems are needed, and all kinds of different products have been invented to get that done. What are the ratings that result from a fire test? Fire test is simple. If you want to, hop on fcia.org after this and watch a video that'll show the hose stream test. It'll show the product burning for a period of time. Many of you have already seen that test because I know our manufacturers have been around the architects to the building officials to show them that. What doesn't take place is the discussion about these ratings. F rating is a flame rating. How long does it take for fire to poke through the cold side of the assembly, the non-fire side, in hours or minutes? The T rating, how much time does it take for the temperature of the penetrating item to increase 325 degrees above ambient at about 12 inches above that assembly. Why is that T rating important? What happens if somebody stores boxes, paper goods, plastic gloves, anything that's flammable on the non-fire side of that assembly? If somebody stores something there, it can catch fire without flame ever poking through that assembly. The H rating, H is Canada optional, but it's mandatory in North America and lots of other places. You go to the Middle East, to the Abu Dhabi, to Dubai, to Doha, and the hose stream test is mandated through specification and in some cases by code. In Abu Dhabi, the United Arab Emirates, they have adopted the Abu Dhabi National Building Code, which is based on the International Building Code 2009 version. Air leakage rating is optional. So these three, FTH, you'll find in most all systems. L rating is optional. It came in 1994. Friends of ours, Rich Walke at Underwriters Laboratories, and his team invented that L rating in 1994 to give a test standard that simulates the movement of smoke through the assembly. Basically what they do is put the assembly in a chamber, put some pressure on it, and then see how much air moves through in cubic feet per minute per square foot of opening area to give it that L rating. The W rating is relatively new. It's maybe 6, 7 years old. We've asked UL to improve it because basically what they do is pile water on top of the penetrating item or on a joint through putting another plexiglass pipe around this penetrating item. That plexiglass pipe is then filled with 3 feet of water to simulate a 3-foot head of water. If in 72 hours there's no leak down below, guess what? You've got an L rating. The weakness of the test, the advantage is, yeah, you got an ASTM or a UL standard for it, but the weakness is that the material has only been in that area for 21 days, 30 days, whatever it takes to condition it. Secondly, the penetrating items never moved, nor has that floor ever moved, and that doesn't necessarily represent what happens in a building during the life cycle. Thirdly, nobody threw some cleaning chemicals or other chemicals on top of that penetrating item just to see if it'll be resistant to it, and then burned it. Fourthly, there's been no water spray or hard water put on that assembly immediately after it's been installed or a day after it's been installed to simulate what happens in buildings. They don't put the windows in on new construction until after, many times, the Firestop's been installed. How does the system resist that? So these are some of the things to be aware of when specifying this W rating, and also the L rating too. The key thing is when you look at the L rating and the W rating, at UL, on the UL standard, after the product is tested for smoke, tested for W, they then put it into the furnace and burn it. That's a key point to watch for as some of these new standards are coming out. ASTM has a new standard on E814 for moving the penetrating items. It's going through the process now. We saw that a negative was provided to slow it down and make sure that the fire test took place after the assembly moved. In our opinion, we'd like to see a fire test take place after the assembly has aged, moved, and been exposed to lots of things as well. We know that the standards development process takes time. We appreciate all our manufacturer partners do to make this standard more reflect what it should in the field as well. Final part of this is the hose stream test. This is probably the best picture there is to show what that hose stream test looks like. That hose stream test is really quite a way to apply a force to the assembly and really does a great job of making sure that the assembly stays in place when this hard hose stream hits it. Stand by for the next webinar. We're going to put the video on it at the next webinar because that's the way we'll show the slides rather than this big analysis. Once the test standard has been run, so they burn this for 2, 3, 4 hours, the hose stream is blown against the assembly, and then they run it in a pattern that goes side to side in a very organized pattern so that the spray of water is hitting everywhere on the assembly, and so that it really simulates force hitting that penetrating item. The ceiling tile dropping and hitting it, ductwork falling from the ceiling as it breaks away from the breakaway connections to the fire damper, and hitting that penetrating item, jarring it hard so that if there's anything that opens up after that penetrating item got hit, the water hose stream will go through it and show up on the other side. The failure mode for that is if water gets through, it's a failure of the fire test. Even if they made it through the fire test and no flame poked through, if that hose stream shows water on the other side, guess what? You then fail that test. Pretty cool stuff, interesting to watch. If you ever get a chance to visit one of these fire tests, find a way to get it done. Many of the manufacturers of fire stopping, the FCIA manufacturers, Hilti, Specified Technologies, 3M, Rector Seal, all of them have fire test laboratories. Many of them will invite contractors, specifiers, and others to come visit their factory and go through an education program. They do a great job. And then they'll take you to their fire test laboratory and show you this hose stream test. It's very, very impressive. Once the hose stream test is done and once the reports are written, a system is developed. All the systems are published in directories. FM has their approval guide. UL has their directories, either print or online. And Intertech has an online directory or a print directory as well. Key things to remember: the time temperature curve when fire testing these assemblies is 0 to 1,000 degrees in about 10 minutes and about 1,900 degrees in 2 hours. So it's a pretty rigorous test for the ASTM E814, the UL 119, or I'm sorry, the ASTM E119, UL 1479. There's one other test that doesn't come up often that sometimes the fire resistance rated construction industry uses, and that's a UL 1709, which is a high energy fire. It's a petroleum-based fire. And what happens is it goes from 0 to 2,000 degrees in about 5 minutes, and then stays at 2,000 degrees for the duration of the test. That's kind of the oil and natural gas industry. Maybe some of the fire stop manufacturers have done some testing on it. You'll have to check with them on it. So let's get to the test and listed systems. And I'm going to just take a couple of minutes. I've spent a lot of time on this in previous webinars, but regardless of what webinar we're in, it's very important to go through this whole assembly. How do we get to the UL certification directory, online certification directory? Start here, ul.com. Scroll to the bottom. At the bottom of the website, there's this gray-black box. Here you'll find on the right-hand side, Online Certifications Directory. Click on that. That takes you to this box. If you know the file number, click on that. Maybe we do C-AJ-2001. It's a plastic pipe, and look at that. It brings it right to it. So if you know the number, click that in. It'll bring you right to the tested and listed assembly. T rating, 0, hour and a half, 2 hour. F rating, a 2 hour. L rating, 7 cubic feet per minute at ambient. So that would be the number that would have to be used, because remember the code said it measures it at ambient and at 400 degrees Fahrenheit. So if it says both, that means you've got to use the worst case, which is the 7, for calculating the number of L's in that 100 square feet of wall area. This one's a plastic pipe. It's got 3 wrap strips around the perimeter of the pipe. They're all butt wrapped, not spiral wrapped, as you can see here, because there's no spaces. And then metal banding is used, as well as metal collars to hold it in place, with the collars bent at 90-degree angles, so that the intumescent wrap strip expands into the pipe, providing an insulating char for 1, 2, 3 hours, whatever the system is. This one's 2 hours. When people say that fire stopping is easy, and you'll see this all over the place, advertisements, contractors, everyone will say, oh yeah, just go get some fire stop product and you're all set. The one thing that we would ask our building official friends and our specifier friends is, when you tell people to do fire stopping, tell them to go get a Firestop system. Just use that one word, system, because the system will result in someone providing this, the test and list system. If the building official looking at an existing building going through and says you've got violations, go get some Firestop, what will happen is they'll come back with a tube of Firestop sealant and put a bead of Firestop sealant around the perimeter of this plastic pipe. That winds up being a fire risk. Why? Because we didn't ask for the right thing. We need to ask for a Firestop system, which will use Firestop products to restore the fire rating that the wall had before somebody poked a hole through it or put a joint in it. Those two simple little words produce a whole bunch of things. In the city of Chicago, for instance, I met with the building department last fall, and they told me they tell people to go get Firestop and fix that, Firestop that opening. So what do? Go to Home Depot, get some Firestop sealant, or Lowe's, or Ace, wherever you want to go. Next thing you know, they've got Firestop caulk around everything. And really, it's not the Firestop sealant that gets the rating, it's the system. It's the recipe. The recipe that says that the floor or wall has got to be 4.5-inch thick, solid concrete wall, or it could be a 6-inch concrete block, or it could be a hollow core precast concrete unit. And that the diameter of the opening is 0 to 1/4 inch larger than the outside diameter of the pipes and conduits, based on the inner space, based on the pipe size. And then any of these penetrating items can be used, polybutylene, ABS, polypropylene. And then wrap strips are used for the Firestop assembly, with a certain number of wrap strips used. If they don't have this recipe, they, meaning the Firestop installer, and we hope it's a Firestop containment worker that's doing this work, a professional, if they don't have this recipe, they have no idea what they're installing. And then it talks about the manufacturer of the Firestop wrap strips. Caulk, putty, or sealant is also installed. Steel collars. So by the time all said and done, this is about a 5-page system. Even a simple system, a metal pipe. This is a Canadian one. FT rating of 0, FTH. So the T in here is the 0. So they've got the F, they've got a T of 0, but FTH, because of the T in here, it's a 0. It doesn't mean it didn't pass the fire test or the hose stream test. It just said that the T rating is 0. All these things are specified in the system. Certainly somebody could have run out and gotten Firestop caulk, Firestop sealant, and installed it in the opening here. Usually they'll put it at the top of the sleeve, the sealant, yet the system says it's got to be at the plane of the floor instead of at the top of the sleeve or at the bottom of the sleeve. Then they might or might not install mineral wool underneath it, and would they get the thickness correct? And secondly, would they do the second thing that's required? Every product data sheet or manufacturer's installation instruction sheet says to smooth or tool the Firestop sealant. If you look at this Firestop sealant, it's smooth. It doesn't look like spaghetti, as can happen when somebody pumps sealant out of a tube. It's been smoothed with either a tool of some kind. A professional will use a spatula tool, specifically manufactured by many of the manufacturer members like Albion, who's a FCIA member tool manufacturer, to make a smooth surface. The UL assembly doesn't say to do that. Let's take a look at the Firestop sealant down here. All it says is that fill, void, or caulk sealant is applied to the annular space for a minimum depth flush with the top surface of the floor or both surfaces of the wall. It says absolutely nothing about tooling it and how smooth it should look, or that it should adhere to the pipe surface and the concrete surface or the inside of this sleeve surface. It doesn't say a thing about that in the tested and listed system. So if you show up on a project site and you're the special inspector, or you're an AHJ looking at the project, or the owner has hired the architect to be the owner's agent and do a little bit of QC on the project. If you see that the Firestop installer is just running around with a tube of sealant, has no system in his hand, and has no tooling in his hand, has no installation instructions, ask the question, hey, could you show me the system that you're using for this type of an application? Can you show me the installation instructions so we can verify that you're getting done what you're supposed to get done? Then, after you ask that question, we would recommend that a destructive test take place. Cut one open, or have the contractor cut it open if you don't want the liability of cutting it yourself. And that's perfectly okay, because that's the way most of the installations go. And then measure to make sure that the thickness of the sealant is as specified in the tested and listed system. How do you do that? Let's say it's fresh material. It's only been in for a day and a half. If it's a latex material, silicone material, or any type of Firestop sealant, there will be some shrinkage that takes place. Why? Because there's solvents or water that cures off over a period of time. So in order to really inspect it and understand if the contractor has installed it properly, a calculation has to be made to the percent solids. And you get that information and the calculation method from the manufacturer of that Firestop sealant to verify that whatever they put in at the initial set was the accurate thickness. In Firestop sealants, the thickness is specified, but if you notice, the thickness doesn't say whether it's wet or dry. Huge question, huge thing to keep an eye on. Back to the presentation. Before we get to there, we've got one more system to take a look at. Let's get back over to the systems. Sorry about that. Talked about plastic piping. Here's one without any collars where a wrap strip is used at the top of the assembly to come up with an F rating of 2 hours and a T rating of 0 hours. Firestop sealant is used as well, and the wrap strip's positioned appropriately. At a head of wall assembly, this one shows a wall that's parallel with the flutes, and the question would be, what happens if the wall is perpendicular to the flutes? Can this system be used? The only way you'd know is to go through the assembly and see what's specified. And here it says wall assembly to be assembled to be centered under and parallel with the valley of the fluted steel floor unit. So that means that this picture depicts exactly how it's supposed to go. The wall cannot be perpendicular to that head of wall assembly. Then take a look at this. The forming material specified, IIG, rock wool, Roxol, or thermofiber. When it says that, that means that that exact material, whichever one it is, has to be used. You can't substitute somebody else's. And in this case, it's an STI system calling for an 1/8 inch wet or 1/16 inch dry. So the spray materials, the spray sealants, provide from the manufacturer and on the test and listed system the wet thickness and the dry thickness of the Firestop assembly for the head of wall. Also note that the sections of mineral wool are to be a minimum 4 pound per cubic foot, 64 kg per meter, kilogram per meter squared, or cubed. Mineral wool bad insulation compressed 50% in thickness and installed cut edge first into the gap between the top of the wall and bottom of the steel floor or roof deck. And they've said a minimum 6 1/8 inch wide section. So the width would be across the wall itself, 6 1/8 inch section. And if you notice, the mineral wool fibers are oriented horizontally and not vertically, and then they've compressed it and installed it as well. The Firestop spray sealant overlaps onto the wall and then back onto the metal deck as well. It'll say in the system how long that will go for. Back to the presentation. We've covered a bit about system selection, and we'll do a deeper system selection section later on. I've had a question come up from one of the people on the call, and I'd like to address it right now. And I think it's a great question, actually. What section in IBC will tell me floor penetrations going into open air areas, pool decks, balconies, require fire stop? If you get back to the International Building Code, the International Building Code calls for continuous fire-rated assemblies, regardless of what's happening on top of the assembly. So if it's an open area and it says it's a fire resistance 2-hour fire resistance rated assembly, and it's open, the penetration is open to that next assembly, that continuity of fire resistance has to be there, period. There's also a second reason. The structural capability of that floor is set up through ASTM E119 or UL 263. Those are the test standards for the floor or the wall itself. The test standard does not test the wall or floor with any holes in it. So in order to represent the ASTM E119 assembly, the assembly has to be solid or protected or continuous. So that would mean fire stop. Why? Because if there were holes in the slab, then the fire attack could come from two sides of the assembly. The fire test, the ASTM E119 UL 263, does fire attack only from one side of the assembly. Therefore, from a structural perspective, the assembly may not make it the length of the fire test if it's got fire attack from two sides. That justifies the need to maintain the continuity of that fire resistance rated in assembly from both sides. Great question. Really appreciate you asking it. Got another question on curtain wall that came up. I'll answer that later on. Secondly, how do contractors select and analyze? So this could be anything. It could be a special inspection agency, could be a contractor. In order to really understand what the fire stop system is that's needed or what should be in that assembly, all this information needs to be known. What's the wall floor? What's the penetrating item? Is there insulation on it or not? What type of insulation is it? How big is it? How thick is it? What's the inner space size? Did it get exceeded? Did it not? What's the joint size? What's the backing materials? What are the fill materials to make this fire stop system work? Certainly, fire stop systems are tested in certain ways. Old systems were tested completely centered, which never happens. Off-centered came next, and then the point contact came next. The testing for this is pretty well across the board available for all kinds of different situations. Now let's spend some time on engineering judgments. I apologize for spending so much time on the testing, but time got away from us. I'm going to spend some real critical time on engineering judgments. The key thing about engineering judgments is if there's a system for something, go with the system first. If there's another system from another manufacturer, even though you submitted a system from manufacturer A, you got to switch to system or manufacturer B because system manufacturer A doesn't have a system for it. If no system exists in the universe, how do you find that in the universe? All the manufacturers know each other's systems. All you got to do is pick up the phone and call their technical department and say, do you have a system for this? And if not, who does? Every day, part of their competitive advantage is that the manufacturers look at each other's systems to make sure that they haven't been beat in the testing game. And it's part of the free enterprise system, and it works great. If you can't find a system in either case, then you have to go with an engineering judgment. That engineering judgment is based on the International Firestop Council's protocol. When you're getting an engineering judgment, the key thing that you need to ask is, what is the manufacturer's position on the engineering judgment? Some manufacturers put this right on the bottom. We believe this will pass the ASTM UL 814, 2079, 1479, S115 fire test. That's critical language for the contractor and the building owner manager to have on that engineering judgment because it puts the manufacturer's stamp on whatever they do. Here's what the industry document says. The International Firestop Council, which is the Manufacturers Association of Firestop Manufacturers, has a guideline for evaluating engineering judgments. Mind you, it says not how to make it, it says how to evaluate it. The evaluation is done by others, construction industry professionals such as building officials, fire stop contractors, and other stakeholders need guidelines for evaluating and using. Those two words you get in a court of law, when it says evaluate and use, and you got all these people in front of it, that says that the evaluator and the user just took suitability for use responsibility for that engineering judgment that will work in that application. Is that fair? I'm not too sure. Why? Because if you look at some of the other pieces, and I'm going to take a look at ASTM E2750, brand new standard for engineering judgments, and you can look and see what it says about it. I'm going to zip through these. I'll put this on the on fcia.org so you can take a look at it. At fcia.org, you'll find this information later this afternoon. This presentation will be published, and you can read this on your own. First thing out of the EJ guidelines is not used in lieu of tested and listed systems. They're based on interpolations that are sufficiently similar in nature or clearly bracket the conditions upon which the judgment is to be given. Those are the two big pieces in the engineering good judgment guidelines. And then it goes on to be based on accepted only for, so if you look at this language, again, it's for somebody else to say, yes, this is acceptable, rather than, unless the manufacturer has on their engineering judgment that they believe it'll pass the test, it means somebody else accepted the responsibility for that. Let's get down to the next piece. This is a brand new standard. I know one of the guys that helped develop it, Rick Royce from Thermofibers, on the phone, so hopefully I do it justice. And if not, Rick can correct me along the way, and we can look at it deeper at our next session. ASTM E2750 is extension of data from penetration firestop system tests. It's meant only for ASTM E814 at this time. Doesn't include joints, so it's not 2079 or for curtain wall assemblies. Developed by ASTM Committee E6, and it's for penetrations only. Falls in ASTM E814. Now look at this. Right in the beginning of it, it says it doesn't itself incorporate all factors required for a fire hazard or fire risk assessment of the materials, products, or assemblies under actual fire conditions. You'll find this, although it's shocking for some to see, you'll find it in all ASTM standards. Because it's done in a test laboratory, you can't really say that it's the exact actual fire in its normal language. I was shocked when I first saw it, but it's something in all of the ASTM standards. It's a extension of fire test results that have not been tested. I would disagree with this one word, Firestop Systems, because it's not a Firestop system unless it's been tested. So it's extension of the fire test results of Firestop systems that have not been tested. So next one is users have to have knowledge and understand the provisions of these test standards. So if you were evaluating these on the other end from the International Firestop Council as a contractor or AHJ, can you say that you know E119 and E814 well enough to evaluate and say, yes, this would probably work? I'm not sure about that. Some limitations: substitution of different test conditions impacts the fire test response test characteristics. On to the next one, should not be used to extrapolate the fire resistance rating to a higher value, and it's got to fall within normal reasonable limits of accepted construction practices. And the statements of this guide are based on a single change to a system. I'm guessing that's only an annular space change or some other parameter, or not multiple parameters. We'll have to dig into that more to understand it as time goes on as well. So whoever uses this has to have an understanding E814 and the fire behavior of the firestop materials. The only way you can have the understanding of the fire behavior of the firestop materials is if you stand there while the fire test is going on to know what it does. And then knowledge of the elements of construction, and understanding of the probable behavior of the underlying construction and the recommended firestop system protecting it. Pretty important stuff. The person performing the evaluations should be the manufacturer's knowledgeable personnel, a registered professional engineer, knowledgeable in fire stopping, independent testing agency, or technical personnel. Under this qualification, I know it sits in the standard, but I would go back to the slide above that says that they've got a full understanding of the fire behavior of the firestop materials. And I would come back down to this and say, does a professional engineer have a full understanding of that by just looking at a test report? Because the test report is part of the evaluation to do this engineering judgment. And if the engineering judgment is done by a professional engineer who wasn't at the fire test, then they have to look at this. Can you do that on paper? Can you not? So this engineering judgment thing is pretty important to understand, and it's pretty important to get right. So that if you look at it, the industry spent lots and lots of time. I think Rick Royce probably spent 5 to 7 years of his life organizing that committee at ASTM to get that standard written. The industry spent a lot of time on it. Do engineering judgments happen? Yes, they do. And I'll wrap this up in the next 5 minutes. Do they happen? Yes, they do. They have to happen because there are conditions in the field that come up when that have not been tested yet by any of the manufacturers. We know the manufacturers are testing like crazy, and we know that they've done a great job trying to get things right. But there's still more to be done, and we know that the manufacturers will continue to do that. We've spent a lot of time on the tested systems, and that's what the focus of today's program was. Tested and listed systems, how do we get them installed to the tested and listed system? If you noticed, I have not spent a bit of time on the methods to pack the fire or the mineral wool, regardless of what manufacturer, what sealant, how the sealant gets installed, and then the smoothing of this. A couple of questions have come up on the discussion on engineering judgments, and what I'd like to do now is get to this part of the slide, and let's get to some of these questions while we've got a few minutes with people on the phone. First one is a note relating to Canada. Some of the building officials do not allow the use of the term engineering judgment, and instead they use custom fire stopping detail. That's a good point, and really appreciate that point from the audience here. The manufacturers actually invented this term in the 80s and 90s, 70s, 80s, and 90s, engineering judgment. It's based on their judgment of what they think would happen if they interpolate the existing conditions with testing that they already have in their array of test standards. And really, engineering judgment, if you look at this, in a way, it's a bit of the testing of engineering. The engineers at UL help design these systems. I know that they've got engineers on staff at both UL, FM, and Intertech, all three, for designing these assemblies. And as soon as you start doing self-certification of products, it sure does help to have an engineer's view, conservative view, and their license, if you will, looking at this as well. I'm not trying to promote that engineers have to do everything, because they don't. Many of the technical staff at the manufacturers are just as qualified and not engineers, and stand by the fire test and know what it is. But the term engineering judgment really is important. Custom fire stopping detail, I'm not sure works, because again, if you go back to those qualifications of the individuals that need to write these things, they got to know what the fire test characteristics of these products are. That really is something that the industry needs to come up with. Custom fire stopping detail, while a good term, I'm not sure it's appropriate for the industry, but I appreciate the fact that that you try to do something different. The next question comes up: what type of application of FM-approved foam block as Firestop is acceptable, and how many blocks can be used to create the Firestop? I guess I'll reach out to the crowd and see if somebody can text me on the question thing. One of the systems for the Hilti foam blocks or 3M foam blocks, or whoever's foam blocks they are, because I'd like to put it up there to answer this question. The question is, what type of application of approved foam block? So I know I've got a picture of a foam block in here, and the foam blocks are installed in a certain direction. They're installed a certain number of them. Here it is right here. So if we take this picture, if you look at it, in this case the blocks completely fill the assembly. The blocks are flush with the wall, so they're in the 4-inch direction instead of the lengthwise direction. And then the system would explain whether to put sealant around it. Somebody just texted me the system, so let's go over to the system design and off we'll go. Thank you very much for testing or for sending that system across. So let's go back to a through penetration Firestop, and it's W-L-4019. Let's see what that brings up. Here's one for Canada. So the recipe on this system will tell me how they're installed. If you notice, they're installed butted. There are no gaps between the blocks. And then it'll tell us the type of cables that are installed, and it has to match exactly. Non-metallic tubing, so that's a plastic ENT of PVC, nominal 2-inch. And it tells me that the blocks installed 5-inch direct dimension passing through the opening, firmly packed to completely fill the entire opening. Either one or a combination of the block types specified below may be used, and they got the Hilti FS657. And then fill material is to be forced between the interstices of the cables, between cable and cable tray, and in obvious openings between the blocks and the periphery of the opening to fill the whole thing. So off we go. There's your system to get that done properly. Really appreciate that, Felix Candejas. Really appreciate you sending me that system. So it says very quickly about how that goes in. And again, the system is the focus. It's not the foam block. It's not an FM-approved foam block or a UL-approved foam block. It's in this case, a Hilti block, and it's the Hilti FS657 with some Firestop sealant that's been installed to this recipe to get a 1 or a 2-hour FT, and that FTH rating is 0. Really appreciate that question. Next question is, what section of IBC, we already went through that question, sorry about that. Moving on, there was another question that came in about, okay, how does a masonry or metal stud cavity wall relate to curtain wall in the IBC? Void between a curtain wall in the IBC. The void between the brick and the masonry backup could create a chimney effect, especially with XPS insulation. That's a great question. Here's a curtain wall assembly as depicted graphically. If you notice, there's a gaposis also at the perimeter of this cavity wall of between the glass and the curtain wall insulation, which would be 3. Oh gosh, where is it? Come back here. Actually 2G. So if you look at 2G, 2G would be the insulation that's used for the curtain wall assembly, extending 39 inches, a meter up, a meter below the wall assembly. So what this does is extends the wall out to the exterior edge before the glass. If it were for concrete block, this curtain wall assembly could actually extend all the way out to the exterior skin of the building if it were a concrete block exterior, making it continuous. However, then in the moisture design part of it, there'd have to be weep holes through that assembly, which wouldn't be all that great for the fire resistance assembly on it because the weep holes may cause a problem. There may be some tested and listed systems. Check with the manufacturers to see on that. This is one area that we're going to spend some time on later in the year on curtain wall design and fire resistance because these are some 2 big areas where fire can take place. Currently at ASTM, the standard for curtain wall only takes the interior fire spread of the assembly. So the floor or wall can be 2 hours, or the floor can be 2 hours all the way to this point for fire spread inside. It doesn't measure what happens if the glass breaks out down below at 3 feet, comes out of the assembly, and then breaks the glass at the level above it and hops into the building at that point. This is called a leapfrog type assembly, technical term obviously, but where the fire laps out the outside of the building, breaks the glass, and comes back in, catches the drapes on as well. So how can concrete block work with the or granite or some other fire-rated assembly? This fire resistance rated assembly could come all the way out to that area and not have a gap or a chimney. The next question is, what happens with foam insulation at the exterior skin of the building in the NFPA 285? That's a different story, different discussion for another day. The fire codes and the energy codes are basically crashing at this point. The energy codes have been increasing like a stock portfolio should at almost 15%, 20% per code cycle every 3 years. They've gone from, with R values, almost double, triple in the last 10 years. When the wall design wants to be thin, it needs a energy efficient insulation such as a foam. When the fire guys show up, they're saying, wait a minute, you've got this foam chimney at the outside perimeter of the building. I need fire resistance. So then you wind up with some kind of a fire resistance gypsum assembly as a fire barrier, not to the term of the fire barrier used in the wall, but a thermal barrier actually between the flammable insulation and the exterior skin of the building, with all of those penetrations sealed as well the way they should be. And what happens is, if there's a breach in that thermal barrier, or if there's no thermal barrier at all, if there's a flammable or fire on the exterior skin of the building, somebody throws a cigarette butt in a garbage can or a dumpster that's on the perimeter of the building, that fire starts and gets inside that building or inside that curtain wall assembly when there's foam insulation, it can then catch fire. Google, if you want, Tamwheel, T-A-M-W-E-E-L, towers in Dubai, October 2013. Exact thing happened. Cigarette butt started to fire. Good question. Next question that came in is, does smoothing the fire caulk really make any difference to the practical fire resistance of a system? Absolutely it does. The question, the smoothing of the fire resistance or the Firestop sealant. If you think about it, the Firestop sealants, if they're not smooth, may not be cohesive altogether in one spot. Take a look at this picture. Let's say, let's go to the next one. Take a look at this picture. Look at the sealant here, how smooth it is. The Firestop sealant has been adhered to the metal sleeve and adhered to the metal pipe. That adhesion is critical for the air leakage rating, first of all. If it's not adhered, there's gaps. If there's gaps, there's air. Where there's air, there's smoke. That L rating, whatever it was, may not be appropriate, may not even work because there's no tooling done. Secondly, the fire resistance rated assembly was tested with the Firestop product smooth and adhered. It wasn't tested as a spaghetti mesh all over the place without adhesion and with maybe gaps. So the smoothing is required because it was mentioned on the installation instructions of the Firestop manufacturer's installation instructions. If it says to smooth it, we've got to smooth it, period. Really great question. Thank you very much for asking that. Let's see, another question that came up. Could we speak about perimeter joints between fire-rated floor and unrated curtain wall in Canada? There is no test standard. Great question. I was just up in Canada last week, actually, and that question came up during our presentations during our education. The test standard in Canada, I should say, in Canada, the ASTM E2307 test has been accepted and specified as the acceptable test for perimeter fire containment assemblies. Is it a Canadian standard, Canadian national standard? No, it's not. Is ASTM international? Are their standards accepted in Canada? They can be. The National Building Code of Canada does have language that says that international standards can be accepted. Certainly in Canada, you want to go with the Canadian standard first, and rightfully so. You all see the Canadian Standards Association, all are fine organizations, done a great job on standards. But for now, there's no test standard. This is the best thing that there is. Next question says, in which iteration of the International Building Code is ASTM E2750 required? Good question. Currently, I don't believe it is. That standard just showed up a year or two ago, I'm thinking, maybe 3 at the most, and I'm not sure if it was ready for the International Building Code for 2015. As a matter of fact, if I were to go to the International Building Code 2015 and look at penetrations and joints, no place in here does it say what to do for an engineering judgment. It doesn't specifically say that if there's no system, then go to an engineering judgment. It says go with a system. The only exception in the code to a system is right here using concrete type assemblies. And what it says is that when there's steel pipes in a fire-rated floor assembly where the annular space is protected with materials that prevent the passage of flame and hot gases sufficient to ignite cotton waste when subjected to ASTM or UL 263, for the period equivalent to the fire resistance rated needed, then a maximum 6-inch pipe shall not be limited to the single rating, and then the size of the opening, 144 square inches. And then it says that it can be installed concrete or grout, full thickness of the floor, or the thickness required to maintain the fire resistance rating. That or the thickness required to maintain the fire resistance rating, you'd get back to here in Chapter 7, there's a table, the equivalent fire resistance ratings. And what it would say is a certain type of, let's see, where the heck is that? A certain type of material, certain grout, certain thickness will get you a certain rating. And that is back over here. So if you take a look at 722.2.1, it talks about concrete to get 1 hour with a silicaceous, or you know what I'm talking about. You get 3.5 inches to get an hour. Sand lightweight concrete, 2.7 inches to get an hour. To get 2 hours, 3.6 inches. And that's continuous, so it can't be broken up in 2 pieces. So think about a concrete block wall. If that concrete block wall, the thickness of the face of the block, if that's 1 inch, then somehow you're going to get 2.5 inches continuous of lightweight concrete, or 3.5 inches, 3.6 inches of concrete in order to make a 2-hour rated assembly no bigger than 144 square inches with metal pipe only. Good question. Thank you very much. So in which iteration of IBC is this ASTM E2750 required? It is nowhere to be found, as far as I know, in the International Building Code. Great question. Thank you. Back to the presentation. I was basically at the end of it, but I'll keep going as long as the questions keep coming in. So I've looked at the typed questions, and I've covered them all. Thank you very much for asking them. At this point, I'd like you to ask to see if you have a question that hasn't been answered, put your hand up, and then I'll call on you, open up the microphone so that you can ask your question. Are there further questions? I see a question from Darren Wellborn. Darren Wellborn, I've opened up the microphone for you to talk. Darren, do you have a question? Darren Wellborn? Okay. Richard Watkins has his hand up. Richard Watkins, do you have a question, Richard? Richard, if you have a question, you can turn on your microphone and ask it. Okay. Question came in on the text. Can we get a copy of this presentation? This has been excellent. I will post this presentation to fcia.org. So take a look here at fcia.org. On the right-hand side where it says Hot News, take a look here. That's where I'll post the presentation or a link to get to it. Thank you. Good question. Okay, here's a question that came in. Let me do this. I'm going to get on the question here from Ron Dre. Ron's got his hand up and he's got a question there. Ron, go ahead. Ron, do you have a question? Or did you type it in maybe? Sorry, Ron, I can't hear you, so I'm going to go back to the other questions. Okay, so there's a couple of questions that came in on the text. First one is for CAJ 1453. So let me get to the tested systems and bring up CAJ 1453. Okay, so I'm going to go back. CAJ 1453. How to apply material that is flush with top surface of floor if the sleeve is extended. Okay, cool. Good question. Okay, so here we go. Here's CAJ 1453. This system shows the sleeve cast or grouted in place, and it does not extend above the floor. In my mind, that's crazy. And the reason why is because sleeves are installed in floors to produce waterproofing, usually, in mechanical penetrations, or in electrical penetrations. They're to isolate the penetrating items from the concrete. Same thing with in copper for plumbing. You're trying to isolate the cement-based material, which will eat a copper pipe or cause formicarical corrosion. You isolate it using a sleeve. But most of the mechanical engineers and plumbing engineers extend the sleeve 2 to 3 inches above the floor so that water piles on the floor here, they don't get a leak down to the floor below. Let's go down and see what it says about the sleeve. In this situation, the metallic sleeve, although the picture, look at the picture here, picture shows the sleeve flush with the floor. The system shows that the assembly, the sleeve can extend 3 inches above the floor or beyond the surface of the wall. So the question is, how to apply the material that's flush with the top surface of the floor if the sleeve is extended. So let's go down to see what the Firestop assembly says. So 3 types of sleeve. Here it says Schedule 5 or heavier steel sleeve, sheet metal sleeve, and it can be either spot welded or flange spot welded, or they can be overlapped, is my guess. The Firestop system says, here's the sealant, that the sealant has to be flush with the top surface of the floor. There's the issue. So let's say that we're in CAJ 1175. The picture of 1175 looks just like what you described to me. But look at where the system is. The system's installed at the plane of the floor, not at the top of the sleeve. That's a key thing to remember that inspectors sometimes miss. That could be jurisdictional or special inspectors that just don't specialize in fire stopping, and contractors that have no idea what they're looking at would miss that too. It's a key detail because the fire dynamics of that sleeve are such that the product may heat up more at the top of the sleeve, might get hotter up here because it's at the highest part of the sleeve. It may heat up sooner than was anticipated, than it would heat up down here. I don't know, but there's something in the fire dynamics that said that they have to install the sealant at the floor assembly. So that means that somebody has to get a sealant tube, a caulk gun that has a long tube, install the backer rod or mineral wool, and then install the Firestop sealant down here, and then tool it smooth so that it winds up just perfect. Great question. Thank you very much for asking. Next question is, what rules should we follow if we have a crack in the wall, and how should these cracks be repaired in concrete, masonry, or drywall? That's a really good question. Cracks in walls do occur. We know that. See if I can bring up the picture of the fire resistance rated wall. I know I got a drywall assembly. So here's a fire resistance rated wall assembly. The best thing to do is to go back to the ASTM E119 assembly or the UL263 assembly in the U400 series and look and see what it says for patching that wall. The Gypsum Association also has a dissertation on patching wall assemblies. Cracks in drywall that are continuous likely might breach the fire resistance rated assembly. Why? Because the fire test was run on a solid piece of gypsum material, anchored a certain way, with the joints taped all together as one piece. It wasn't tested with holes in it. It also wasn't tested with cracks in it. Maybe one of the manufacturers, U.S. Gypsum, National Gypsum, Georgia Pacific, has tested these assemblies with cracks in them. Really where you need to go is the manufacturer of the wall to see what crack is allowed. In masonry, there are, well, let me go back to one other place. Let's go back to the International Building Code and look at the definition of joint. Because basically what you're talking about is a small gap could be a joint. The definition for a joint under the International Building Code, Chapter 2 is where you'll find the definition of the joint. In Chapter 2, sorry about that, let me get to it. Here's the definition for joint in Chapter 2. It says the opening in or between adjacent assemblies created due to building tolerances designed to allow movement in any plane caused by thermal, seismic, wind, or other loading. The opening in or between adjacent assemblies. Opening, I don't believe, is a defined term. Let's see if we can find opening and see what it says. Opening, nope, not a defined term. So let's go to joints under section 715. So joints installed in or between fire resistance rated floors and walls shall be protected by an approved fire resistance rated joint system for a time period not less than. And the exceptions are here. Floors within a single wall, protected by a shaft, mezzanines, roofs where openings are permitted, et cetera, et cetera. And then it talks about the curtain wall assembly, and then it talks about the UL 2079. So let's talk about a crack. Let's say the crack is not continuous. Is that a joint? I don't think so. If you look at that definition of a joint that we just put up there, which talked about, it sits right in the charging language of 715, joints installed in or between fire resistance rated floors shall be protected. Joints installed in or between. So is a crack a joint? That'd be a good question to ask. Kind of a gray area in the code. Second question would be, does it mess up the continuity, though, of that fire-rated assembly? If the answer is yes, then okay, maybe we have to treat that with a fire resistance rated assembly. Maybe the Gypsum Wallboard Association has a way to patch those. If the patch takes place using clips, there are some fancy clips that are used, marketed by, I believe, USG has them, National Gypsum has them, Hilti has them, that are backing clips that hold patches of drywall and allow the assembly to pass the hose stream test. Otherwise, it's building a frame out of the wall from stud to stud horizontally and then putting a patch on. The Gypsum Association GA 600, maybe we'll spend some time in that. It's a good topic for a webinar. When do you fire stop? When do you not? And when do you patch a wall? Thank you for asking that question. Next question is, does the language in ASTM E2750 pass liability for the viability of an EJ for the manufacturer issuing the judgment to other parties? Ooh, good question. Let's take a look at ASTM E2750 and see what it says. The scope of the guide, because it covers extension. And the guide's based on principles. Then it talks about the type of the building. Then it talks about prediction, measure the fire test response. And then here it is, the disclaimer. Standard does not report to address all the safety concerns associated with its use. It's the responsibility of the user of this standard to establish appropriate safety and health practices and determine applicability of the regulatory limitations prior to its use. The second thing that it might say on this is, and I don't know for sure, it talks about the who, talks about the how. As far as responsibility, I'm not sure it really says who's responsible for it. Let's go to the very end of it and see what it says. Now, it really doesn't have much in here about who's responsible for that engineering judgment. I think this standard really, the ASTM E2750, is to give guidance to those that are making engineering judgments. Again, back to the suitability for use statement. It makes sense to ask for in the engineering judgment the manufacturer to state that they think it'll work when subjected to ASTM E814 or UL 1479. Good question, thank you. Next one is, what type of damper do you recommend when we have to reroute a smoke barrier horizontally for bulkhead or rated ceiling of a room? There's a horizontal smoke. Is there a horizontal smoke damper or a regular radiation damper may be used? That's a great question. You know, I can't tell you I'm an expert in which type of damper gets used where. A couple of their friendly fire damper manufacturers have spent time with us in the Total Fire Protection System Symposium and the Barrier Management Symposium. Ruskin and Greenheck, they're great companies. They're advertisers in Life Safety Digest. I'd reach out to Greenheck or Ruskin. At Greenheck, you could give a call to Mark Sorge, S-O-R-G-E, and he might be able to help you. Next question is, what about 9 control joints not exceeding a maximum width of 0.625 tested in accordance with ASTM E119 or UL 263? So back to the International Building Code. This is on the cracks in fire-rated walls. This would be in, let's see, that would be joints. Let's get the joints real quick. Fire-resistant joints, 715 point. Let's see, 0.9. Oh, there we go, 9. There we go. Control joints not exceeding a maximum width of 0.625 inch and tested in accordance with ASTM E119 or UL 263. So the question is, does this mean that you don't have to fire stop a joint? That's my guess. And if I'm not quite correct, Sonia, please let me know. So the exception to having to put in a joint system, as soon as you say that this opening area, control joint, tested to UL 263 or 119. So that would mean that the wall itself had a control joint of 0.625, likely not all the way continuous through the wall. That control joint is typically there only to control cracking and where it might occur in the slab. So if that control joint is simply a half-inch deep or less, or more, and does not penetrate all the way through the assembly, and it was tested and passed at ASTM E119 or UL 263, then it doesn't need a fire stop sealant in it. That's basically what that's saying in the code. Great question. Thank you. So let's see. I think that covers the texted questions. I'm not seeing anything new there. So if you have a question on the text, go ahead and hit it again. I'm back to the questions and the hands up. On the questions, I see quite a few. So let me start opening up the microphone for people. Ron Dre, you had your hand up. I've opened up the microphone, Ron, for you. If you have a question, go ahead and ask it. Ron Dre, are you there?
Yeah, Bill. Not so much a question, just a comment. We were talking about the intumescent blocks. I just noted that those are supposed to be used in a running bond and not a stacked bond configuration.
A running bond and not a what?
Not a stacked bond configuration.
Okay. Can you expand a little bit on running bond versus stacked bond?
If you had stacked bond, you would be basically stacking a fire-resistant brick or block on top of each other, whereas you would stagger the joint by 50% in a running bond if you're stacking them. So they kind of interlock, if you don't understand what I'm saying.
Great point, Ron. Really great point to point out there. Rather than what Ron, I think, is saying, and I'll open up the microphone to make sure I got that covered. The blocks are staggered such that there are no gaps, continuous gaps in the blocks, such that one joint where block meets block does not show up in the same place as the block below it. Ron, is that the point you were trying to make?
Yeah, basically, a stacked bond, if you had a 4 by 8 inch block, you would stack one directly on top of the other with no staggered joint. A running bond basically calls for joints to be staggered by 50% of the length of the block. So you'd always have a 4-inch overlap in a 4-inch by 8-inch block.
Great point, Ron. Thank you very much. On to the next question, Don Darling. Did you have a question? I've opened up the microphone for you, Don. Hey, Don, any question?
I did have a question. When it comes to looking at the different ratings, that would be, for example, an F rating or a T rating or an L rating, on an assembly that may have an F rating that meets the requirements but not have a T rating, how do you determine what assembly you would use in order to achieve both ratings required?
Thanks, Don. Great question. Question is, let's take a look at this system. This is an F rating of 1 and 2, a T rating of 0 with the system that Ron Dre was just talking about with the staggered blocks such that you have always greater than 50% overlap. The T rating comes with the penetrating item. These are all copper cables. The penetrating item, I think, is a plastic pipe, and then there's probably a steel cable tray. So the T rating is 0. What we would have to do to find the T rating that matches is go back through the system selection process, look at the manufacturer's system selection, look at the UL system selection, and go find another system that has a T rating equal to what the code has required. And the code usually requires an F rating of something and a T rating of something. The Firestop system may have to have things happen to it. These metal pipes, for instance, may wind up getting insulation on it to get the T rating up to 1 hour as required by code. Great question. Thank you, Don. Really appreciate that. Felix Candejas. Felix, did you have a question? Okay. Next person, Jack Fingold. Did you have a question? Or did I get it already? I've opened up the microphone for you to talk if you can, Jack, but if you have a question, feel free. If not, that's okay too. Okay. Jerry Dugan, either senior or junior, I've opened up the microphone. I know you had a regular question and asked it already that I answered. Do you have another question, Jerry? Okay, no question there. Next question mark up is Ken Isaak, I-S-A-A-K. Ken, I've opened up the microphone. Ken, question? Okay. I had a question come in on the text. How do you determine the CFM in a 10 by 10 wall? So here's what you do. Let's say this wall is 10 by 10. Better yet, I'll get back to this picture. This wall, pick a 10 by 10 area. How many penetrating items are there going through the wall? Add up the L ratings for those penetrating items. And then what's the system at the head of the wall? And what's the L rating for that? Come up to less than 50, and you've got your number. Great question. Thank you very much for asking it. Next question is from Mark Fuji. Mark, I know I've answered a couple of your questions on the question marks. Mark, did you have a question you wanted to ask? Okay, nothing there. Medhat Metri, I've opened up your microphone. Can I don't know if you can speak or not. Not going to work. Okay. Michael Phillips, I've opened up your microphone. Do you have a question still? Okay. Nicholas Kaufman. Nicholas Kaufman, I've opened up the microphone for you. Do you have a question? No question there. The next question that came in is, let's see, two questions that came in on the text. If there's a need to provide a sleeve for future use, is there an arrangement where a metal cap is placed on both ends or a certain minimum length of sleeve extending beyond both sides of the wall? Good question on the metal cap on both ends. I don't know the answer about the metal cap thing. I imagine that might hurt the T rating if there's one required. A Firestop product could be used in a blank opening to provide a fire resistance rating. It might be easier to mess with and easier to take off and put a new penetrating item through at a later date. Would it be on both sides of the wall? It'd be wherever that Firestop system for the blank hole allows. Next question is, what happens when the L rating CFM is exceeded? That's a good question. In that case, let's say you're the special inspector and you counted up and you found it's too much on the too many L's for that 50 square foot of wall or 100 square foot of wall. Then in your report you'd have to say that it was violated. That gets communicated immediately. According to the International Building Code, it's immediate communication to the contractor that something's happened. Now the result is, that's where the arguing and yelling and screaming comes in. The general contractor may have not instructed the mechanical, electrical, plumbing contractors on the placement of their items not to exceed the number of penetrating items going through a certain section of the wall. Or they had enough and the Firestop contractor used the wrong L ratings. That's when you got to figure out who's guilty in that situation. And that can be easier said than done. Good question. Thanks for asking it. Next question, I've got Paul Nickerson had his hand up. Paul, do you have a question? And it's good to see you last week in Toronto. Okay, no, nothing there. Next question, Ramil Santiago. Ramil, I've opened the microphone. Do you have another question? Yeah, I can't hear you. Okay, on to the next one. Sonia, did you have another question? Sonia, I've opened up the microphone. Okay, I know you asked a couple questions on the text as well. Next one is with Steve Hewitt. Steve, I've opened up the microphone. I know you had a question that you typed in too. Any further questions? Okay. Next is Thomas Allison. Thomas Allison, do you have a question? Nothing there. Next is Darren Wellborn. Darren, I've opened up the microphone. Do you have a question? Okay, nothing there. Next is our friend Saifuddin Tahir over in the UAE. Saifuddin, do you have a question?
Yes. If we have very specific requirement in the project specs, talk about leakage, smoke and gas tight penetration requirement, in that case, what we select to install is a leakage system or rated system?
Leakage,
fire rated system.
Leakage or what, Saifuddin?
Leakage, the smoke tight partition requirement, like smoke and airtight specification speaks about. Okay. So in that case, we select the L-rated system, even though the partition is not fire rated? I mean, the barrier is not fire rated?
Great question, Saifuddin. Thank you. What Saifuddin is referring to is the smoke barrier and smoke partition, which is two different things. The smoke partition has no fire rating to it. It's a zero fire rated assembly, but it has the smoke language similar to what the smoke language is in the smoke barrier for the air leakage rating. And it says restrict the passage of smoke. In our opinion, the L-rated assembly is needed in both. And this also applies for Canada, because in Canada, the fire separation, which is what a fire barrier is called, is also required to resist the passage of smoke in certain situations, and a fire separation may or may not have a fire resistance rating. So we've got both conditions, whether you're in U.S., Canada, or the UAE. So the question is, do I need to use a Firestop system with an L rating in a smoke partition which is not rated? I would say yes, you do need to use an L-rated Firestop system. And the reason is that the L-rated Firestop system has a quantifiable resistance to smoke that's been tested to UL 1479. The test standard wins in the court of law as to the suitability of use statement for the product used in specific applications, whether it's water resistance, fire resistance, adhesion testing, cohesion testing, whatever it is, the ASTM standard is known as a consensus standard and an industry standard, and that's what's expected as the minimum to get by. So therefore, I would answer the question, yes, an L-rated Firestop is required for a smoke partition. That's me personally. Will a AHJ let something else be used? I'm not sure. I don't think they should, because the test standard already exists for an air leakage rating, and they should stick with what the test standards are, the UL 1479, UL 2079, and ULC S115 with the smoke resistance. That smoke resistance is specified as it's got a test method for it, and it really needs to be used. Really great question, Saifuddin. Thank you for asking it. Another person has a hand up, Mike Reynolds. Mike Reynolds, I've opened up the microphone for you if you've got a question. Okay, no question from Mike Reynolds, so I'll close that back up. Let's see if I've got any more questions. Looks like I've caught everyone on the questions. So I don't see any more being typed in. If you have further questions, please go right ahead and type them in. If you don't, we'll wrap up the program and end this chapter in the, one more question. Do you see any problem with automatic doors that are located in smoke-resistant walls? These doors have sensors, and they will remain open until they automatically close. Good question. I can't tell you I'm an expert in the door programs. And what works in smoke-resistant walls for those doors. I can tell you that testing has changed, that I believe positive pressure is required now for doors, and negative pressure. Again, I'm not an expert. I can't tell you. All I can tell you is that the testing's changed, and they do need more smoke resistance. The automatic closers on smoke-resistant doors would have an automatic closing device such that if smoke dampers went off, the doors automatically close. But I can't tell you I'm an expert in that. Thank you. Good question. Next comment came from Mike Reynolds. Thank you, Mike. Recently, Hilti has improved the Hilti block which will allow stacking the block without offsetting the vertical joints and seams. Good point. Thank you. Glad to know that the manufacturers continue to test their products to come up with designs that match what is reasonably foreseeable to occur in the field. That's a very important piece, because We know that the contractors, and I lost where that assembly was, we know that the contractors, some will install it incorrectly that way as well. Thank you. So just sum it up, FCIA does believe in the design, and look at the CIMM. If you look at this acronym, this is developed with Saifedean Taher and many of our other friends from the United Arab Emirates and Doha, Qatar, as well as Dubai in the Middle East. Saifedean's on the phone now. It's 9 hours ahead. It's almost 10 p.m. his time. Thank you for being on the line, Saifedean, and many of our other Middle East friends from around the world. We do these programs every once in a while at 7 a.m. Central Time so we can catch them earlier in the evening so that they're not put out during their personal time. The DCIIM means design, coordinate, install, inspect, and maintain and manage. Test and listed systems installed by an FCIA member FM or UL contractor, inspected by qualified inspectors, the ASTM E2174-2393 standards. Hopefully they're IASAC 291 accredited. And then maintained and managed by the building owner using FCIA member FM companies, UL qualified companies, and accredited firms. So thank you very much for spending some time for it with us. If you're a specifier, please feel free to hit us at info@fcia.org. There are free specifications. Again, if you want some of those, hit us at info@fcia.org. There's a free spec at fcia.org, and then under publications, look on the left-hand side, 078400 specification. You'll find that right over here on the left-hand side, 078400. There's a specification that has all this. It's in Word document as well as a PDF. So really appreciate you spending time with us. Watch for our next webinar where we'll dive into the installation. And in that webinar, I'm going to take out the FM standard and the UL Qualified Contractor Program, and we'll go through those in great detail so you can understand what takes place to become an FM contractor, a UL contractor. For the specifiers, it'll give you the opportunity to understand why you're specifying UL or FM contractors and what it means. I'll also cover the DIIM. I'll do a little bit on testing, a little bit on inspection, a little bit on maintenance. Why? So you can get your AIA credits throughout and make sure that they're HSW credits as well. So at this point, I'd like to thank everyone for being on the call. If you have questions, bill@fcia.org, info@fcia.org. If you want a free manual of practice, info@fcia.org, and we'll get you a free manual of practice if you're a specifier, if you're a building official or a fire marshal. If you're not a member, we hope you'll join FCIA and become part of this group that funds these programs. This is the way we can do it for free. Otherwise, we'd be charging $20, $30, $50 every time. Thank you for attending. Appreciate the opportunity to spend some time with you, and we'll look forward to talking next time. Again, we'll post this presentation at fcia.org. Look on the right side of the fcia.org website. Over here under the hot news, it'll take you to a link and you'll be able to find the presentation I just did. Thanks again, everyone, and we'll look forward to talking soon. Bye for now. Bill McHugh from the Firestop Contractors International Association signing off.